Hello guys, welcome to the Civil Engineering YouTube channel. Please subscribe our channel for more civil engineering updates. And today our topic is to how to calculate the self weight of the beam, or to how to find the dead weight of the beam, that what's its weight of beam itself. Alright, so I will show you how the calculation carried out. For example, I'm considering it by an example. This is taking an example of the simply supported beam of length 10 foot, and I'm going to draw it in 3D. This is for example, this is a beam. This is a beam in 3D, right? Beam in 3D. So this is the these are supported by one support here and one support here, supported in two direction. This is the beam. This is the length of the beam is 10 foot, as we have shown here, the simply supported beam. The width of the beam here is considering 2 foot, while the depth of the beam is considering it by 3 foot. There is a depth, there is a width, and this is the length of the beam, right? So we are going to interested in to find the self weight of this reinforced concrete beam. This is R.C.C beam, right? R.C.C beam. So it's composed of a reinforced concrete beam. So to find its the self weight, we have a formula of the weight is equal to the unit weight of the object multiplied with the volume, right? So this we know that the unit weight of object, for example, in this case, the unit weight of the reinforced concrete of which the material is composed, and this is the volume of the object of which is. So this is the volume of the object, while the this is known as the unit weight of the object of which the material is composed. This is R.C.C. So we should know that the R.C.C gamma value is of 145 pound per cubic foot, right? This is the standard value we are known with it. The standard value known to us of the gamma of reinforced concrete is 145 pound per cubic foot. So we know the unit weight, and we will find the volume of this beam, how much the length, width and depth. We will multiply these two with each other. We will get the self weight of the beam, how much the weight of the beam on these two supports. We will get the self weight of the beam, right? So now by doing the calculation, as we know that the weight is equal to the gamma, as we know that the gamma is 145. I'm again writing it, and the gamma value is 145 here because the reinforced concrete is used, and the volume will be length into width into height, right? Like length into width into height. Width is the width and this is the depth, right? So this is equal to the volume, and here we have length is 10 foot, width is 2 foot, and the depth is 3 foot. So by calculating, we get the 60 cubic foot is the volume of this beam, right? This is the volume of this beam, 60 cubic foot. So we will multiply these two numbers. 145 is the unit weight of this beam, and 60 is the volume of this this object, this beam. So 145 into 60, we are getting with 8700 pound. It means almost of 8.7 kilopound, right? So we are getting with this pound. It means if the self weight of the beam which this beam has and these two supports is the self weight is calculating is 8.7 pound, 8.7 kips, and 8700 pound will be acting the weight of the beam at the center on this beam. This is the dead weight, or we can say the self weight of the beam, and this is the method how to calculate the self weight, how to calculate the self weight of the beam. It's very simple. You should know the basics, the basic formula, that the weight is equal to the gamma into volume. We should know the volume of the shape object, and we should know the material property of which the material is composed. For example, it may be the other property, it may be the wood, and we should know the volume of the material. So we should multiply, we get the weight of the object, right? This is the way how to calculate the self weight of the beam, by multiplying the volume of the beam and multiplying the reinforced concrete unit weight. So we get the weight. As we also know that the units of the gamma is pound per cubic foot and the volume is cubic foot. So these units cancel with each other, only remains with the pound. So that's why we get in the weight self-weight of the beam or something in pound. We can also get in other unit if we know the density of the member of the material in another unit, maybe for example in kilonewton per meter cube, and we should know the volume in meter cube. So we cancel with each other, so we get the weight in the kilonewton unit. We can find the self-weight of anything in any unit by just knowing the basic formula. Right, I think this video will really help to find the self or dead weight of any object. And if you have any question, please comment, and don't forget to subscribe our channel for more civil engineering updates. Thank you for watching our video.